So, on the basis of kinetic theory, write an expression for pressure exerted on an ideal gas. You know, pressure exerted on ideal gas is 1 by 3 rho v square, and that is the expression you have to derive, for which you draw a cube. It's made up of an area of cross section A. The vibrations are along x axis, along y direction, and along z direction. Let's only consider along x direction. At an instant of time when delta t is there, the distance moved by the molecule will be Vx into delta t. And considering A is the area of cross section, the volume will be Vx into A into delta t will be the volume of the gas. Considering n number of molecules are there per unit volume, small n is the number of molecules per unit volume, and you have to multiply it with the total molecules. Therefore, the total molecule will be n into Vx into A into delta t will be the total molecule. But having said that, in this situation, in kinetic theory, we're considering exactly half the molecule is striking the surface and the half the molecule is moving away from the surface. The total molecule striking the surface is exactly half of it. And you're going to calculate the change in momentum. When it strikes the wall and bounces back, you know the final momentum, it's P final and this is P initial, is minus mb is the P final and initial is mb. So P final minus P initial will be minus mb which is minus 2 mb. And you want to find the mass, therefore you want to find the mass. Supposing this is along x direction, you just put x and 2 mvx. Similarly, we'll have y direction as z direction. So to find the mass m, you know this is the number of molecules that's striking the surface. You can simply multiply this with m, because small m being the mass of one molecule. So it's m n vx A into delta t by 2 will be the mass here. Okay, so then on substituting here, the 2 and 2 will get cancelled. So you will get minus 2 m n vx A delta t into Vx, which will make it Vx square by 2, where 2 and 2 gets cancelled. That's what is a change in the momentum delta P. Now dividing this by time, that is the delta T again. You know this change in momentum by time is the force. So when you divide this by delta T get cancelled and delta P by delta T becomes your force. When you divide this by area, when you divide this whole thing by area, the area get cancelled. So divide left side also by area, thus it becomes the pressure. Therefore the pressure along x-axis is called P1, which is mnvx square. So you can ignore the negative sign. So thus this is the pressure along x-axis. The pressure along y-axis will be mnvx square, vy square, and P3 is mnvz square. And average pressure therefore is P1 plus P2 plus P3 by 3, which is mn into vx square plus vy square plus vz square by 3. So you know that vx square plus vy square is a velocity vector, v vector. The magnitude, okay, you can call it as v vector the whole square. Mn itself is rho. Density is mass by volume. Mass here is m is the mass of one molecule, n is the number of molecule occupying the total volume v by v. So v and v get cancelled. This density is mn. So you can replace mn per unit volume. If average pressure is per unit volume, thus the average pressure per unit volume is this 1 by 3 rho v square. Okay, so this is the formula and this is the question that they have asked. So then next thing is B. This is about section A. Section B. What is the average velocity of the molecule of an ideal gas? So the average velocity of the molecule of an ideal gas is 0, because the velocities will be in all directions. Generally a molecule will be in all directions, and since it's a vector, velocity is a vector, they'll all cancel out. So it will have vibrations in all directions. So the average velocity of the molecule, you just have to mention this. The velocity is a vector and it is in all directions in an ideal gas, and so the average velocity of the ideal gas is 0. So that counts as this. And next is C. Define mean free path of the molecule. What type of molecule is associated with the molecule of the gas? A define mean free path is the distance traveled by the gas molecule between two successive collision. Between two successive collision, the distance traveled by it is represented by lambda, that's known as mean free path. So define it. The distance traveled, the average distance traveled by the gas molecule between two successive collision is known as mean free path. What type of motion is associated with the molecules of the gas? The Brownian motion. What is Brownian motion? Is a zigzag motion. That means the molecules will travel in all possible directions. Can you see a gas is occupying a cube, it will expand to fill it. So in the process, the gas molecules move in all possible directions, which is known as a zigzag motion. Zigzag motion, which is also known as Brownian motion. So what type of motion is associated? Brownian motion. So that answers this question. Then there is another question which is an OR question, where the internal energy of ideal gas is purely kinetic. Yes, the internal energy of an ideal gas is purely kinetic. There is no potential at all. No potential simply because it exerts no force of attraction. Ideal gas exerts no force of attraction, and hence there is no potential energy. So it has to be only purely kinetic, which is dependent on temperature. So that's the answer you are supposed to write for it. Okay. The part number 2, I don't understand that question itself. So then just prepare yourself for the part 1 alone. Okay. So let's go to next thing. This answers the 35th question, which is a case study. So let's go to next question. It's the 34th question. Power is the rate at which work is done. It's measured in watts in SI unit. It is measured as unit to calculate the electricity bill. An engine is 4.9 kilowatt power. Is used to pump water from a well which is 50 meter deep. So this is 50 meter deep. This water, and it's going to pump out the water. What's the work done by this engine in 1 hour? So if this is the power, power is the rate at which work is done. Okay, and so then here the work done is nothing but potential energy, and the potential energy is mgh. But do you know the mass? We don't know the mass of the density, you don't know the mass. Okay, so let's see, g is 9.8 into height is 50 meters. In 1 hour, the question is 1 hour. 1 hour has got 3600 seconds, and the power of the pump itself is 4.9 kilowatt, means 10 to the power 3. With this you can find what is the mass. Cross multiply and get the mass. What is the work done by, they're asking work done itself is power into time. Is power into time, which is 4.9 into 10 to the power 3 into 3600. You multiply this, you get the work done, which will be in joules. Multiply this and write the answer. Give the dimensions of power. Power dimensions is work done by time, which is force into displacement by time, which is ml t to the power minus 2 into L by t, which is ml square t to the power minus 1. That will be the dimensions of power. That answers B. This answers A. And C, what is the power? What is the mass of the water it can pump out? Here it is. Just have to cross multiply this. So 3600 into 4.9 into 10 to the power 3 by 9.8 into 50 will give you the mass of the water that been pumped out in 1 hour. So that answers A, B and C. Then next is that is mass, which has to be in kg obviously. So then write this answer. Next is or question. Calculate the volume of the water it can pump out in 1 hour. Volume of the water it can pump out in 1 hour. You know the mass, and density is mass by volume. So volume therefore is mass by density. The mass is this calculated mass here, you can substitute. By density of water is 10 to the power 3 kg per meter cube. On doing this, you will get the volume of the water pumped out in 1 hour. I'll just show you the answer. So here it is. The volume of the water pumped out it should be this 36 kiloliters or 36 10 to 10 to the power 3 liters. And the mass of the body, the mass of the water is the same calculation that I said. Your answer has to be like this. Okay, so that completes the sum. So let's go to next question. So this is the next section, in reverse order, section D, 33rd question. 33rd question, differentiate between stationary wave and progressive wave. Stationary wave and progressive wave. I've shown you the video also. A stationary wave is one where it will stand between like this, it will be stationary, it will remain stationary. Okay, in a stationary wave, and as you saw in the video, this will go up and down. At some point, all molecules, or what to say, all points will cross the mean position simultaneously. But here, not all particles, because this is progressive, it keeps on moving. The progressive wave keeps on moving, it keeps on traveling like that. So then therefore all points will never cross the mean position simultaneously. Then stationary wave, as you can see, is stationary. The points at the node will remain stationary. The particle at the node, or you can say the particle at the node, all points will cross, all points or particles in the medium will cross the mean position simultaneously. All points less particles will never cross the mean position simultaneously. That's point number 1. And point number 2, the nodal points will remain stationary. Nodal points, the particles or particles at the nodes will remain stationary. Particle at the node will remain stationary. No particle will remain stationary. They're just asking for, I think, only two difference between stationary and progressive wave. As the name suggests, this is stationary and this keeps on moving, it's progressive, and so you can see these two differences. Let's go to next. The next thing is they have given session B, or y of xt is equal to 20 sine 4t minus 2x. Okay, this is the wave. Write an expression for it when reflected by a rigid boundary and open boundary. So when it is hitting on a rigid surface, the pulse which goes and hits on a rigid surface, it's going to come back like this when it's getting reflected. Onward pulse and the return pulse. So then you see that the y is also becoming negative and x is also becoming negative. X was positive here and x is negative in here. The y and x, both of them are negative. So for the reflected wave, reflected y of xt will be, y is also becoming negative, so minus 20 sine 4t plus 2x, because x is also becoming negative. When you put a negative here, it becomes positive. So this is a reflected wave on rigid boundary. Then next is a reflected wave on an open boundary. The reflected wave on open boundary. For an open boundary, y of xt, if you're going to write, in an open boundary, the crust will come back as crust only, onward and return. So then the y is always positive, only the x is going to change. So the y of xt will be 20 sine 4t plus 2x. There's no y negative. So this is the reflected wave on rigid boundary. So that answers this question. So let's go to next C and discuss the formation of